Hey everyone, we are going to look at what happens when the second derivative test fails. Just a reminder, the second derivative test, if your first derivative is 0, your second is negative, less than 0, then you're concave down and so you have a max. Or if your first derivative is 0, your second derivative is positive, that means you're concave up, so you have a min. But what happens if your first derivative and your second derivative are both 0? This is when the second derivative test fails. So let's start with a couple of familiar functions. Say we're looking at y equals x to the fourth. We know what this looks like. We've seen it before. It kind of looks like a parabola that's slightly like flatter on the bottom. And y prime is 4x cubed and y double prime is 12x squared. So both y prime and y double prime are 0 when x is 0. But there is no sign, since y double prime is always positive when x isn't 0, it's just concave up the whole time. So we have a minimum and there's no point of inflection. But if we look at, say, y equals x cubed, another graph we're familiar with, like just looking at it, we know we have, and I drew this slightly poorly, it's actually flat at the origin. But we can see there's a point of inflection there. So like if we look at y prime equals 3x squared and y double prime is y double prime is 6x. Y prime is always positive, so it's always except for when x is 0. And so it's always an increasing function. And then at x equals 0, both y prime and y double prime are 0. But y double prime changes signs at the origin, so we have a point of inflection. And we don't have a min or a max, we have a plateau point. So we have a plateau, and we have a point of inflection. And when you're justifying a point of inflection, what you say is that y double prime changes signs when x is 0. So those are a couple things that can happen. Obviously, you could have a minimum as well, like if that was a negative x to the fourth. So let's look at a slightly more complicated example. Say we have y equals x to the fifth minus 2x to the fourth. So remember, we'll find our first and second derivative. Y prime is 5x to the fourth minus 8x cubed. And I'm going to factor that just for the sake of being able to use it, and then I'll take the second derivative. So I can factor an x cubed out, leaving me 5x minus 8. That helps me to find where this guy equals 0. So, and actually I'm just going to go here. Y prime equals 0 if x is 0 or if x is 8/5. Because remember, if you have a product that's 0, one of those two pieces has to be 0. So to find out whether or not we have a min or a max on that, we can look at our second derivative. So finding our second derivative, remember, go back from that original one, not the factored one, unless you really like the product rule. I don't think anybody does, though. So 20x cubed minus 24x squared. And again, I'm going to factor this guy because it's actually easier to use. I can factor a 4x squared out, and I get 5x minus 6. So looking at when x is 0, y double prime is 0. So that means our second derivative test fails at 0. When x is 8/5, y double prime of 8/5. And by the way, again, I don't bother to necessarily find an answer to this. I just find the sign of it. So if x is 8/5, that's a positive, and then 5 times 8/5 is 8, so subtracting 6. So we have a positive times a positive. So this guy is positive. And remember, if you have a positive, it is concave up, looking like that. So we have a minimum. But what happens so what's the deal with x equals 0? So when the second derivative test fails, we need to figure out, does y double prime change signs? And also, does y prime change signs? So if I look at, I'm just going to draw a quick number line. When x is 0, I know y prime is 0 and y double prime is 0. If x is negative, if I plug negatives in here, I get a negative value when I cube it, and I get a negative value when I plug something in negative here. So I have a negative times a negative. So y prime is positive to the left of 0. When x is positive, depending how far I go, I'm going to throw this 8/5 in here too because it might matter. And actually, I'm going to back up. I'm going to go even crazier here. We can find where y double prime is 0. And that happens if x is 0 and if x is 6/5. So I can throw 6/5 in here as well. So we're trying to figure out what's going on with all of the signs and everything here. So if I throw a negative in here, I get a positive times a negative, so I get a negative. If I throw something between 0 and 6/5 in, I'm going to throw a 1 in because that's easy for me to think through. So if I throw a 1 here, I get a positive times a negative, so that's negative. 6/5, my second derivative was 0. And beyond that, it's positive. We had already done that. So I can definitely see I have a point of inflection at x equals 6/5. Because f double prime changes signs. Now looking at x equals 0 though, it's negative and then 0 and then negative. X equals 0 is not a point of inflection because there is no sign change for y double prime. So x equals 0 is not a point of inflection because y double prime doesn't change signs. And then looking at what's happening with my slopes to figure out if I have a min or a max, if I look at y prime, if I look at, say, what happens when x is 1, I have a positive times negative, so I have a negative there. So if my slope goes positive to 0 to negative, uphill, flat, downhill, x equals 0 is a maximum. So it's a 0 because it's a max because y prime changes from positive to negative. And I'm off the screen a little. So it gets, as you look at this, you can tell from the fact that it's a little bit of a jumble here, it gets kind of complicated and you have to do a lot of really careful thinking and analyzing and looking at, like, do we have a point of inflection? Well, we do if y double prime changes signs. Do we have a min or a max? Maybe, maybe not, depending on what happens on each side of things. So if you're trying to ascertain if you have a min or a max, look for the sign change in your y prime. Positive to negative for y prime, obviously you have a max because you're going from uphill to downhill. If your y prime goes negative to positive, you would have a min. So that's what we can do. So this will get better as you do a little practice with it, and I know this is kind of weird and complicated stuff. It gets better with practice. Isn't that how most things are?